everyone, and now we are on the experimentation part on the bananas. So everyone knows that bananas will turn brown after some time. But what if their environments are different? Now this is what we will find out by doing this experiment. But first, we need to follow our safety protocols. We have our appropriate gear as you can see. So first, we have our lab gowns. Second, we have our gloves. And lastly, they have their face masks. And now, I will discuss about the setups and materials used for this experiment. First, we have the bananas. Second, we have our lemons. Third, we have our salt water. Fourth, we have our ice bath. And fifth, we have the hot water. And now, the setups. So our first setup is the control setup, but it is sealed. Second setup is our unsealed control setup. Third setup is the acid setup. We will shower it with the lemon juice. Fourth setup is the salt water setup. Fifth setup is the ice bath setup or the cold setup. And our last setup is our heat setup or the hot setup. And now, we will start with the procedure. So our first procedure is to peel and cut the bananas.
But before that,
What even causes a banana to go brown?
well, bananas contain these little enzymes called polyphenol oxidase, or PPO. And whenever PPO interacts with oxygen, it causes a chemical reaction known as enzymatic browning. This reaction forms what we call melanin, the same dark pigment found in our hair and skin. A banana's browning is simply a part of its ripening process. The darker it is, the riper. Alright, back to the procedures.
With that out of the way, we will now do the procedures for the setups. So for this first setup, we will now wrap it in a plastic wrap and it will be fully airtight. And then our second setup is the unsealed setup. So we will do nothing with this. And then our third setup is the acid or the lemon setup. We will sprinkle lemon juice on the banana. Our fourth setup is the salt water setup. We will pour some salt water on the banana. Our fifth setup is the ice bath setup. So we will put the plate of the banana on the ice bath. And our last setup is the hot setup. So we will dip the banana in the hot water for at least 30 seconds.
So while they heat the banana slice, I'll tell you how the experiment will work. We're exposing the banana slices to different factors to see how the enzymes will behave, showing us different activities of the enzyme PPO and how we can conserve a banana longer. And after a period of time, we will rate how brown each slice are from a scale of 1 to 10, 1 being the least brown and 10 being the most brown. After that, we'll come up with a conclusion that explains the results. And before I forget, this video supports good health and well-being, quality education, and responsible consumption and production from the Sustainable Development Goals.
And now, with that out of the way, we have come to the end of our experiment. But we will come check on these bananas for 5 minutes for 30 minutes.
And after a little bit of waiting, we finally got the results. We won't go into much detail for the control setups as they're only used as a reference. The unsealed one browned at usual rates, while the one that's sealed was slower cause less oxygen. Okay, now onto the acid setup. And boy was this fascinating. Even after an hour, there was barely any browning, only a slight change in color. And this makes sense. Lemon juice has citrus acid which lowered the pH of the banana, inhibiting enzyme activity and slowing down the browning process. This makes for a great conservation method if only the lemon could do something about spoilage. For the saltwater setup, it was definitely less brown than the control setup as shown with the scores. This is because the salt limits oxygen/water activity as salt can draw out moisture. The cold setup had similar results to the saltwater. There was minimal browning here as well because we left the banana slice on a cold surface, which led to low temperatures that slowed down the chemical reactions and reduced enzyme activity. This is why refrigerators are great and probably the best for sustaining food for long periods of time because it also deals with spoilage problems. But the heat setup on the other hand was a whole different story. Even from the beginning it was the most brown, and as time went on it just got darker and darker. This is because high temperatures boost chemical reactions, increasing molecule movements, enzyme activity, and even denatured the PPO, which accelerated the browning process. So in conclusion, what can we get from this about enzymes?
So, from the experiment, we can conclude that enzyme activity can differ depending on the factors they're faced with. High temperature temperature boosts their activity more, while low temperatures, low pH, or anything that limits oxygen can reduce and slow enzymes down, giving us many great ways to conserve our bananas and food in general. Best being refrigeration, and lastly, whatever you do, never leave your bananas in hot places. That's all for today, folks, and remember, it's not just chemistry, it's banana chemistry.
Thanks for watching.